So today we are reviewing compound interest. For compound interest, you're going to have this as your equation. Where the n is going to equal the number of times compounded. Now remember, because t is always going to be in years for us, if we said that this was monthly, then n would be 12. Now we'll try and use this on a couple of questions. So for this first one, the 4,000 is going to be the P, the 6% is the R, and the 5 the T. N will be 4 because it's quarterly. So when we write out this problem, we'll have 4,000, 1 plus the 0.06 over 4 is going to be 4 times 5. You'll plug that into your calculator, and you'll come out with 5,387, right around there. And we'll just round to the nearest whole for this. But we'll have that as our answer. For number 9, it's going to be a little bit different. So we're using the same interest rate, we're using the same amount of time, or not the same amount of time, we're using the same initial amount. So we'll have 16,000 equals 4,000, 1 plus 0.06, but this time it is monthly, so it'll be over 12 to be 12t. And we're trying to find the t. So we'll divide both sides by 4,000, so you get the exponential by itself. 4 equals the 0.06 divided by 12 is going to be 0.005. So this right here is 0.005. So we add 1 to it, we'll have 1.005 to be 12t. We'll do the snail, and we'll have log of log base 1.005 of 4 equals 12t. We cannot put this into the calculator like this, so we'll have the change of base, log 4 over log 1.005 equals 12t, and we'll have, and when we take this part of it, this equals right about 277 point, we'll say 95, and that's going to equal 12t. We'll divide both sides by 12, and we'll have t equals 23 point, we'll do 16, that's fine. So it would take just over 23 years to go from 4,000 to 16,000 on this problem. If you have any questions on compounding interest, please reach out. Otherwise, have a good day.